Hello everyone, welcome to Microsoft Build 2017. My name is Eugene Chuvarov. I'm a senior software engineer with Microsoft, and I'm here to talk to you about provisioning Azure infrastructure with Terraform. This is part 2 of OSS-based DevOps in Azure. I strongly encourage you to view part 1 from my colleague Arun. It's available on the Build website, on the same site that you're viewing this video from. So let's go ahead and get started. So what is Terraform? Well, Terraform is a tool to provision infrastructure into Azure. But before we talk more about Terraform, let's take a look at the options available to us today to deploy Azure infrastructure. Clearly, the easiest one, and probably the most accessible, is Azure Portal. If you go to Azure Portal, you're able to create new virtual machines, new virtual networks, subnets, and other pieces of infrastructure in a very easy, intuitive manner. However, that process doesn't lend itself very well to automation. And plugging into pipelines, such as described in the previous session, the CI/CD pipelines, that's not available to us through Azure Portal. So that brings us to the other options. And a very powerful one is using ARM templates, which is basically JSON files, to author infrastructure and to basically codify it and then use something like PowerShell or Azure CLI to provision it into Microsoft Cloud. And that works extremely well for a lot of scenarios. Another good option, and the one that's actually I'm going to talk to you about today, is using an open source tool called Terraform to provision infrastructure into Azure. This tool is multi-cloud. It supports different cloud providers. It's also hybrid. You can provision infrastructure on-prem as well as into the cloud. And it's fully open source. You can download it for free. It's a single executable file, very easy to get started with. We have partnered with HashiCorp, the makers of Terraform, over the past 12 months to really extend support for our cloud of that product. So we believe it is close to world-class today, and we're definitely looking forward to making it really world-class in the near future. So let's talk about the features of Terraform and what makes it a very good tool to integrate into your CI/CD pipelines, as well as for automating infrastructure provisioning. So Terraform is a tool that allows you to write, plan, and create infrastructure as code. So how would you write infrastructure with Terraform? Terraform uses a proprietary language called HashiCorp Config Language, or HCL for short, to allow you to define pieces of infrastructure. And we'll look at an example of that in the next slide. So it's very similar to ARM syntax in that sense, except it's not JSON, it's HCL, but it's declarative syntax that defines what your infrastructure should look like in the cloud. After you write your infrastructure using those config files, you're able to plan it. And the planning is actually one of the key features of Terraform, where it allows you to have what is known as a dry run mode. So with dry run mode, no pieces of actual infrastructure are attached in Microsoft Cloud. Instead, you're able to visualize what is going to be provisioned from your console. And we will also take a look at the demo that's coming up at the end of this presentation. So finally, another advantage of Terraform is the fact that it's very parallelized. So it tries to optimize the infrastructure provisioning process as much as possible. So there's multiple threads of execution. However, there's also a dependency chart that comes in there. And the dependency chart indicates that certain resources have to be provisioned in order because they're dependent upon each other. So the typical workflow or the typical process of creation infrastructure with Terraform looks like something like the graph below or at the bottom of the slide, where you write infrastructure as code using those config templates. Then you plan and determine what will happen before actually deploying to Azure. You deploy. Then your infrastructure changes, where certain things come in and out. You modify your templates, you plan again. The Terraform determines the changes that need to be applied, and it pushes it back into Azure. So here's what an HCL syntax looks like. And here I pasted an example of creation of a virtual network in Azure, as well as a subnet that belongs to that virtual network. And you can see that there are certain references there that start with $signs. Those references refer to variables that we have defined outside of this specific template that allow us to make those templates more dynamic and obviously more configurable. Another thing that I wanted to point out here is that the subnet it has a reference to virtual network name that clearly shows the dependency of that subnet on the preceding resource, which means the execution will not be parallelized, but instead sequential in this case. So having defined our infrastructure as code using a set of config templates with HCL, we can truly achieve parity between the staging, development, and production environments, which allows us to minimize the bugs that result from going from one environment to the other. It's the same Terraform code that provisions all of those resources in different domains or different environments. And some of the use cases it helps address is such as those that basically allow you to replace the dedicated staging and testing environments, saving money, and also allows you to speed up infrastructure provisioning to where basically you don't have to wait for somebody to initiate that process, but because you have a set of codified config templates, you're able to go and actually deploy that after certain approvals. So one of the visions of DevOps is truly accomplished via basically encoding your infrastructure into a set of config templates such as HCL. Now I would like to go ahead and switch into demo and actually show you a little bit of how Terraform works. In my demo, I'm showing you how to provision a simple Linux virtual machine into Azure using Terraform. And what you're looking at here is basically a template that's very similar to Azure Quick Starts, a virtual machine simple Linux that has several files defined within it. Azure deploy.tf, variables.tf, and some Terraform TF vars. We'll get to those in a second. But in a nutshell, this is the HCL script for configuring the storage account, the container, public IP, virtual network subnet, and the VM itself. As you can see, this language is very easy to read. It clearly has references to certain variables, as well as to resources that have been defined previously. And those variables, one of the good practices is to isolate those variables into a separate file. We chose to use them in variables.tf, so that way you keep all of the variables that can be customized between the deployment runs separately from the actual code that deploys this. So how does this work? Let's switch to the terminal, and let's go ahead and try to provision this template. But before we provision, remember how I said that one of the key features of Terraform was the ability to have a dry run before the actual execution. So the way it works is you type in Terraform plan, and this evaluates the Terraform config file, and it will show us shortly, it's showing us now, what resources it's about to provision into Azure. At this point, no resources have actually been defined. However, if you pay close attention here, you will just see the plan says 9 resources to add, 0 to change, and 9 to destroy. Well, why is that? Well, certainly I didn't want to take a pure chance on my demo, and I already have defined the resources. I already ran this template previously, and these are the resources that I created. So the resources are basically a virtual machine, a public IP, everything that we saw defined in the template. But I will go ahead and re-execute this template shortly. But before I do that, I want to also demonstrate that you can actually create fairly complex infrastructure using Terraform today. And to illustrate that, we converted a couple of other templates from quick starts, such as the one with Active Directory, high availability to domains. And the way it looks is, if I do Terraform plan again, it will provision a large number of resources, or it will show us the plan of provisioning a large number of resources, such as 22 to add, 0 to change. It will provision actually primary domain controller, a backup domain controller. It will put them behind load balancer, and also add all of the supporting infrastructure to that. And so the templates, those Terraform templates are available at the links at the end of my presentation. So I really strongly encourage you to check those out when you have a chance. However, since this template actually takes a little bit of time to provision, I will go ahead and go back to my simple VM Linux and go ahead and actually deploy that to show you how it works. Via Terraform apply. And of course, I misspelled Terraform. So at this point, what's happening is the local state that I had previously is being evaluated what's actually defined in the template. And because I have created this infrastructure before, it's going to say, hey, those are the differences, and those are the differences that I'm going to apply. All right. So as you can see, we're starting destroying some infrastructure. And again, all of those templates are available at the links right here that I strongly encourage you to check out. One other thing I wanted to call out is just there's a couple of setup pieces that need to happen before you start provisioning infrastructure using Terraform. And those setup pieces are fairly known to anybody who has actually set up service principals before. In Azure CLI 2.0, you can do it with a single command, and we provide the instructions on actually doing that in those templates as well. So the templates or the links that I'd like for you to check out is the webinar we delivered together with HashiCorp, Azure DevOps Delivered. We also talk about Packer, which is a tool to create your virtual machine images in a similar manner as you see with Terraform via basically config files. Terraform Quick Start templates is the ones that I talked about just now and showed you. And then getting started with Terraform on Azure is the blog we authored on showing you how to get started using Terraform and provision your first VM. Finally, we take our feedbacks very seriously. We strongly encourage you to email us with anything, any questions, or any feedback that you have for us. Here's the email address. And I really hope you enjoy the rest of the build sessions. Thank you.